All right, good morning, good afternoon, good evening, whenever you're watching this video. Hope you're doing great. Also hope you're not getting sick of proofs yet. This is a short chapter, a lot of work, and I know that you're working hard, so I really appreciate that. So keep it going. Let's finish strong with this chapter. You had the homework of the first proof and then the middle one on the back side of the worksheet. I'm just going to work through these two proofs with you to make sure that you understand. Hopefully you've given these some good thought and aren't just copying them down, because I think we all know that that doesn't help either one of us. So looking at the proof up here for number 2, what do I see here? I see YA is congruent to ZC. Okay, so we're good with that. B is the midpoint of AC, and then we have the perpendicular lines. Now, some of you may have started with the perpendicular lines. I'm going to start with B being the midpoint of AC, and I'll explain that a little bit more later. So, if you start with B as the midpoint of AC, what ensues? What follows? Okay. Well, I would then know that AB is congruent to BC. Okay. And why is that? Definition of, I wrote down the wrong term here, of midpoint. Allows me to state that those two segments will be equal to each other. Okay. Now from there, the next part would be the perpendicular part. Well, maybe I should strategize, like I said earlier, as to which triangles we want to, or how we want to prove these triangles congruent. So we all know that perpendicular means right angles. So I'll go ahead and say this, that those are going to be right angles. Putting that down on paper, I hope you can then see that we're going to prove the triangles congruent by side angle side. Okay, so that's how we want to attack this, not the hypotenuse leg. So I'm going to go ahead and state this, that angle A and angle C are right angles. And the reason, definition of perpendicular. Okay. From there, if we're going to use side angle side, I need to show that those two angles are equal to each other. So I'm going to go ahead and say that angle A is congruent to angle C. And let's say, let's see here, all right angles are congruent. Okay, we have to make sure that those are all the same measure. Okay. So we've got a pair of angles congruent. We've got two pairs of congruent sides. We now have side angle side. So I can put down number 5. Side angle side, triangle, YAB is congruent to triangle, ZCB. Okay. Now if that's true, ABY, this angle here, and angle CBZ, that angle there would have to be congruent. Now I want to make sure that no one confuses this. I think some people would look at that and think to themselves they're vertical angles. They're not, okay? Vertical angle to this angle here would be that angle there, okay? And so I just want you to make sure that you understand that that's how it would be, okay? So with that being said, I'm going to say the proof, angle ABY is congruent to angle CBZ, and the reason is going to be CP-CTC. Corresponding parts, which those angles are, of congruent triangles, which we've proven, have to be congruent. Okay? So there's the first proof. If you need to pause a little while longer and take a look at it, go ahead and do that. I'm going to move on to the second proof down here. Okay, and the second proof, here's what we have. We said yesterday, I gave you the hint yesterday, that you're probably going to prove triangle FLA congruent to triangle FKA first. FLA, K. And we're told that LF is congruent to KF and that LA is congruent to KA. Okay? So as I look at those two triangles, I hope it was pretty simple to recognize that AF was congruent to itself by the reflexive property. Okay. All right. So if I go ahead and mark that down, oh, I have congruent triangles, right? Side, side, side. Okay, so I'll go ahead and say something like this. Triangle FLA is congruent to triangle FKA by side, side, side. Okay. All right. Now from there, I asked you to go ahead and prove the other two triangles congruent, JLA. So if I draw this out, something like this, J, L, A, and K, J, A, J, K, A. So what I'm going to do is I'm going to mark those two congruent to each other. All right. Now, I would hope that you guys are seeing this, but if you don't, not a big deal. We're going to continue to talk about this tomorrow. But it's this, that this angle right here is the same angle as this angle right here. Okay. And we've been talking about the last couple of days that if these triangles are congruent, this angle is going to be congruent to that angle by CP, CTC. Okay? So I'll say angle FAL is congruent to angle FAK by CP, CTC. Corresponding parts of congruent triangles have to be congruent. Okay? Now, some of you may have made this mistake, and if you did, I completely understand. This segment right here is congruent to itself by the reflexive property. And you may have thought that since we proved that segment congruent, that I don't have to prove this segment congruent to itself. The problem is that JA is not the same as FA, so you still have to prove JA congruent to itself. Okay? So JA is congruent to JA, congruent within both triangles by the reflexive property. Okay. So if I mark that out, 4 marks there. Okay. I then have congruent triangles by side, angle, side. Okay. So triangle JLA is congruent to triangle JKA by side, angle, side. Okay. Now that I have those two triangles congruent, would we then know that LJ is congruent to KJ? You better believe it. Okay, so LJ is congruent to KJ by CP, CTC. All right. So now I hope that you guys got that. I mean, if you got that one, that's awesome. It wasn't a super hard proof, but at least that tells me that you're starting to analyze these pictures correctly and see all the little intricate details within the pictures. Okay? All right, so that's it for the homework. If you still didn't get it, let me know, and I'll try to help you out when I get back. Thanks. Have a good night.